Well, I have a prop for today.
What? You never have props. A brick? Hey,
How the
you
hell
can't
are you going to get
replace me
data
with the
in here?
brick. You can't replace me with the brick. It's not going to work. We'll figure it out, all right?
Well, hello again, Matthew.
Hey, Ryan, how you doing today?
I'm doing well. Are you ready to try to simplify the cloud?
Well, I hope so. I see we have two guests to help us do it.
Yeah.
I'm looking forward to
We'll
it.
give it a good try.
Good.
Yeah, I know it's been a while. I see you've got some new IO hardware.
Yeah. Had to up my game, slowly smarter, right? Yeah.
I got a little rug going.
Yeah, that's quite a bit of rug that you got. Oh, that looks good.
All right. So let's go ahead and introduce our guests that we have on today.
Let's do it.
Yeah, so we have Rich and Anthony, who are going to talk to us a bit about how they've used Databricks and machine learning to do some cool things for a customer of theirs.
All right.
And what I hope to get out of all this is how they get data in this.
Absolutely. Hey, what's its name? You got to have a pet name for that, right?
Yeah.
Is that pet Rocky, Stony?
I need a Matthew.
Oh, you can't replace me with that. I'm sorry. I have way more personality than a brick, I think. Right.
All right. So, Rich and Anthony, why don't you go ahead and maybe introduce yourselves and give us a little bit of a feel about what you're going to talk about today.
Sure, certainly. So, Anthony Martin, I'm a cloud solution architect out of the Buffalo, New York area. And what we're going to talk about is kind of a generic case study of a client that we've worked with together, along with another client of ours, Trey Talbot, to handle big data processing in Azure, utilizing and kind of determining which the appropriate services, because there's quite a few to choose through, for the different requirements that we have with our client.
Yeah, no, data is certainly growing at an explosive growth or explosive rate with our customers. They're looking for ways to make sense of that data and be able to do interesting things to, predict the future, if you will, or, make informed decisions. So in Databricks is just one of the plethora of services we have, I know, in Azure to be able to help customers do that. So looking forward to kind of hearing how this actually was applied to your customers. So,
yeah, I want to hear how a brick can predict the future, please.
Yeah.
I'm looking for that one.
Yep.
Hey, so I'm Rich Johnson. I'm a cloud solution architect as well, and Anthony and I kind of teamed up on this effort here at this particular customer that happened to have a pretty ungodly amount of data for weather data, and they had spent some time trying to do some things on their own with another implementation, a Hadoop implementation, and just weren't getting very far, just the amount of effort to manage that service and to get the kind of performance for some of the simple reports they're looking for. So this Databricks just happened to come along towards GA and Azure back in the spring, and it's just like at that time Anthony suggested and others like, hey, let's try this new service that's just going to general availability, and we were quite surprised and pleasantly surprised with what we found and how well it worked.
Okay, so you said two things that I'd like to click into a little bit. You said a lot of data. So, like, can you quantify that in terms of just like sheer, the volume, in terms of size?
Yeah, Anthony, you might want to go into that because I think you got a few notes on it, but it's pretty big.
Yeah, so we have over 600 gigs of data, compressed data coming in per day.
Per day? Holy cow.
Okay. Whoa, back that up. 600 gig a day?
Yeah, when you were saying 600 gigs, I'm like, yeah, that's decent. But
I was like,
you say a day.
Is that really a big database?
Per day was the kicker. So.
Yeah.
Oh, yeah, wow.
That is a lot of data. Okay.
So in a month, we're talking close to 20 terabytes or so, and you can extrapolate it over, for larger time frames, for sure.
Someone's going to watch this video, Ryan, and they're going to go, man, if we could have got that on on-prem storage, we'd be rich.
Yeah. We got some storage vendors that would love to be all over that. So, and then the other thing that you said was Hadoop. I know that's another solution for storing, large quantities of data and being able to report against it. And it's not I don't want to say it's a bad solution, but do you want to highlight what maybe some of the challenges are in hosting in that environment, or maybe what sorts of things that a customer has to take on the responsibility for when they're storing data in that type of environment?
Chris,
Just to
I had a question for
yeah.
you. Take that. So just from a Hadoop standpoint, right? There's a lot of care and feeding just to operate and manage a Hadoop cluster. I mean, you often need some very specialized expertise. So the amount of effort that just goes into that, and that not only that, and keeping up with patches and upgrades, and on top of trying to tune things, it can become very challenging if you don't have those kind of resources and very deep resources on premise or on your team to actually do those things.
Okay, I'm glad you said that, because that was what I was hoping you were going to say, that using a service or a capability that is an as-a-service solution in Azure, certainly merits well or bodes well for a business looking to do interesting things to explore data. But they don't have to worry about like you said, the care and feeding, the administration overhead, the technical intricacies of how these pools of machines communicate with one another. We just abstract that all away from them in with the Databricks.
Exactly.
Yeah. Okay, so let's jump into a little bit about what you guys did. We talked about a large amount of data certainly. There are other solutions that they had explored, and were they using Hadoop before?
They were. So they did have an HD Insight cluster.
Okay.
And believe it or not, the CIO of this company had kind of gotten hands-on and was doing some of that work. And, they ran into some of the challenges in terms of performance, learning curve, experience with the solution. Weren't an expert in the technology, and they were looking for something to process it a bit faster at a lower, more cost-effective rate. And they also had the need for a lot of different users inside the organization to collaborate on the end solution to get insights out of that data.
Okay. Cool. Go ahead, Matthew.
Oh, no, I think that's one of the other challenges is just not the data volume that comes in. A lot of time it's just now you have to democratize the data. I mean, that's kind of the buzzword that's going around, right?
Yeah.
And when they get inside these really expensive, very complex data systems, they don't get democratized, right? So.
Yeah. All right, so let's go ahead and I think you had some slides that you're gonna kind of walk through to get us kicked off and talk about kind of explain what you guys accomplished and what you started with, and then we'll jump into some demos.
Great. All right, so we were able to show our slide deck here. So this is kind of the generic case study of how we did big data processing and analysis in Azure using some different data services and Databricks. So let's first talk through, what was the customer challenge, the requirements, what are we trying to talk about here? And we do have a little bit of a screenshot of some early whiteboarding sessions as we were working through this. But really a core part of the client's business here is exposing data through APIs to their clients. And that's, as we talked about, there's significant usage, over 40 billion API calls per day, which is generating that volume of data that we talked about. This is generating revenue for the client. So it's really important to have some sort of caching layer in terms of how do you expose this API to clients. So they expose their APIs through a CDN provider, and that CDN provider is Akamai. And that's because when you have that many requests coming through, you don't just want that hitting your particular on-premises or cloud-based data store. You need it where your end users are, so they use a CDN for that.
So this is weather data. I'm looking for weather information from my zip code. It doesn't make sense for somebody sitting right next to me who also is interested in weather data for my zip code to hit the database, hot. So that's where the caching layer can come into play, right?
Exactly. And if you think about that weather app that you have, you're looking at, hey, what's my forecast today? What's the next 5? What's the next 7?
Right.
I'm going to check different locations where I might be traveling. So that sort of behavior.
Okay. Yeah.
And so you said the customers are already making money on this, right? So have you guys done an assessment of what kind of the return of investment kind of forecast is? Is it a year, 2? How quick did they come back with monetizable value here?
That's a great question, but we have not made it to that point.
Not yet? Okay. That's fine. That's fine. You said money. I woke up and I was like, oh, free money. But it wasn't.
Some of the commercial clients, right, based on the amount of hits on that API, they're able to monetize it. So that's kind of the thinking there.
Mm-hmm. Okay. That's good to know.
So because of all that, and if you think through, if it's not hitting your infrastructure, how do you know how clients are utilizing your API? So you really need to understand that is. So in terms of what sort of trends, what times of days are the most frequency? How can we combine this data with actual weather to understand client usage patterns? Are they only checking when they think storms are coming, and so on? Is there abuse of the APIs happening from different cell phone providers or technology providers? So all that sort of information to understand and gain insights from how the APIs are utilized helps them make business decisions. So,
okay. And I see some other bullets highlighted here that we already talked about. Not wanting to patch and maintain hardware and software. That's the Hadoop path that, like I said, is perfectly valid and viable, but that was a problem they wanted to, or challenge they wanted to overcome in this solution, or in this customer's case.
Exactly.
Yeah. Okay.
The solution needed to be scalable, not only in terms of data, which it's growing and growing over time, but the different types of data processing they wanted to do. So if they wanted to do, let's say, batch processing today, so they want to operate, maybe they'll run this on some sort of nightly frequency or run it on a certain time of day. If down the road they decide, hey, we want to do this more of a stream processing solution, or if we want to do add some machine learning on top of that data, they didn't necessarily want to throw apart the solution or piece in different pieces and parts. They wanted something that was going to scale in terms of data and the different types of data processing they could perform on that data.
Okay.
So did you guys share then how long it took from kind of conception to pilot?
We didn't share that. We haven't talked about that yet. Rich, do you recall the time frame?
I would say, and it wasn't a full-time effort on Anthony and my part, but I would say from the concept, what they're trying to do, to moving data around to things like Azure Data Lake Store, and then actually getting some reports and significant queries out there, probably a 3 week period.
Holy cow. Okay.
Oh, what?
Wow.
3 weeks? I thought you could say 3 months. I was like, oh, yeah, that sounds pretty decent, pretty average, but 3 weeks.
That's fast.
Wow.
Yeah.
That is
Yeah,
fast. Okay.
Pretty quick, and we were surprised, like I said, kind of on the ramp up and learning curve, both being brand new to Databricks, so quite pleased.
Yeah.
I have to put in a comparison for another customer I'm working or helping right now with some plant floor related solutions, and we talked to them about Databricks 2 weeks back, and did a very high level overview for the customer, and talked to them about a week and a half after we spoke to them, and they were able to get up and running themselves and moving data into it. We had expected to go in there and have to do a lot of hand holding, but they had some technical expertise, were able to rapidly mobilize around Databricks, and they've got millions of records going into it already. So.
Yeah. I don't know how your regions are, but it's very difficult to get a actual Databricks architect or someone to work with. Those guys are so busy. Just about every customer I know in our region is either kicking the tires or doing something significant with Databricks. So it's good test to how useful and powerful the tool is.
Cool.
Yeah.
Okay. So go ahead and carry on. I don't want to derail or interrupt, but just wanted to kind of throw that tidbit in there. I'm pleasantly surprised with kind of the rapid development capabilities of it as well.
Oh yeah.
Yeah. So that's a good segue. So let's talk through what our approach for this POC looked like. So the first thing that we wanted to understand was, what does this data actually look like? So we worked with the client. We got some sample test data. We loaded that to Azure Storage. As we kind of mentioned, we weren't too concerned with the storage mechanisms, but there's lots of different data processing technologies to potentially work through in the Azure ecosystem. Rich and I kind of picked a couple that seemed the most appropriate, and we kind of divided and conquered here. So we tried a couple different things out, and ultimately we decided, based on some of these requirements that they had here, so they needed to be able to handle corrupt source files. A lot of times from their CDN provider, they get some corrupt files. That's just happened. So we wanted to make sure that we could work through that pretty seamlessly. The learning curve was another big piece that we've talked about already. They need to be able to pick it up quickly. It couldn't just take a long period of time and have someone that's really worked with the technology for a long time to pick this up and work with it. And they also needed it needed to be automated. They didn't want just someone that would spin up the cluster, clicking buttons through the portal. They needed to automate it, schedule it so that they could focus on their business.
Okay.
So once we kind of divided and conquered, we pretty quickly saw the Databricks looked very promising, and that was we showed it to the client. they liked what they saw, and then we kind of utilized that as the service that we were going to work with going forward. So then Rich and I kind of then came together. We fleshed out the rest of what the POC solution would look like with Databricks. And then finally, we added some visualization technology. So not only could we work with the data and process it and get the correct formats that we wanted, how can we start to visualize and gain some insights from that data as well?
I got a question for you. So other than the source files potentially being corrupted and whatnot, did you guys have to worry about any like data scrubbing, data, I don't know the word integrity, but really kind of the data's clean. It's not bad data. It was good data for most of these sources. Or did you guys pretty much already kind of walk into a really nice green field and, it's pretty sterile and a lot of data is pretty intact other than maybe some corruption along the way?
Yeah, outside of the corruption, there wasn't, we didn't come across any issues with bad data per se, but the data did need to be broken apart, and we'll see a little bit of the demo because, if when you're accessing APIs, the query string that comes across has a lot of, they jam a lot of information into like a single thing.
Okay.
Understand the different pieces and parts of the API that are being hit and what are the parameters that end users are supplying to it, required some manipulation to report on it.
Okay, I got you.
And to further understand, I mean, obviously they're ingesting data as well. Is that the case here, that they're getting data from vendors or, other weather sources and so forth that they're aggregating? Is that what's feeding?
So there is different pieces of the organization that get weather and data from other third parties.
Okay.
But this piece was really, hey, we have these CDN log files on how
okay, got it. Okay, yeah.
How can we process that?
Yeah, so it's coming from that. Okay, I see. Okay.
Of course, there's definitely some benefits for potentially combining it with other data sets in the organization that they're looking at now.
Okay, I just wanted to kind of understand that flow. Okay, I got it.
How real time was it? How close to real time was it?
So ultimately, initially they're landing on a daily processing solution.
Okay, all right. So at least 24 hours. That's 600 gigs, man.
Yep.
Ryan, I don't even think you could work that fast.
That's a lot of logs.
Yeah.
Yeah.
Just a few.
Yeah.
Okay. All right. I'll be quiet. Sorry for the interruptions.
Cool. So, Rich, I'm going to hand this off to you. The idea here is, now that we kind of talked about the customer challenges and the solutions, and we talked about, hey, there's a lot of different Azure data services, Rich was going to kind of walk through and give an overview of some of the different pieces and components that are available.
Okay.
Sure, yeah.
So I just go real quickly, Rich. I see a slide here, lots of stuff on it. Help me simplify. So I see a lot of components. So hopefully for the customers that look at this, they don't, oh my gosh, it's so big.
All right.
Well, if I had my digital pen working, I'd circle them and simplify them too. Like
there you go. Okay.
So there you go. So Anthony's already ahead of me, but
good.
So, I've been at Microsoft about 20 years, and I witnessed the birth of Azure and Microsoft, and like many of us old timers, I was a skeptic that is this thing really going to take off? People going to give it enough time to mature and take off that it'll actually become something significant and useful? So I've gone from that whole spectrum of doubt and disbelief, having seen other technologies, to the point where definitely a believer. And especially when you look over the last few years, the sheer amount of data services and scale that's practically limitless for our customer, and how quickly we can spin things up versus I was an old guy installing racks of servers and hands and having
running installers, clicking next. I agree.
Yeah, so Ryan, you were in diapers about that time. Yeah.
I mean, to witness how quickly we can spin up, 60 compute nodes on a petabyte of data in minutes. Versus, hey, I gotta plan this, I gotta justify it, I gotta get budget for it, and maybe 6 months later you start having hardware arrive in your data center and having room to put it somewhere and enough power to power it. So the fact that this stuff has really taken us this far, and we can do things like we've been able to do with this little POC for this particular customer, is just significant. So definitely a big believer, and as you guys know, is working in the same kind of a role here at Microsoft. You just see, how quickly now and the snowball has really started rolling, how quickly people are realizing for large data and analytics what they can do in the cloud is just, it's almost impossible to do in your own data set. So,
yeah, I hear they're looking for a pitch man, Rich. And, if you're interested, I might be able to make that connection for you.
All right. Kind of do that day in, day out. But
yeah, we do, don't we?
Let's just kind of jump into slides. So I won't spend, there is a lot. It's kind of a busy slide, but if we look over to the left, we have some services for getting data into Azure or from another cloud provider or wherever. Things like Data Factory or import-export services, and then even underneath that, some of the IoT type technologies for streaming data on the lower left there. So things like Azure IoT Hub and Event Hub, they provide a means in this IoT crazy world where we're take the example of a manufacturer who's just instrumenting maybe a 300-ton press, all kinds of sensors and data points that can be gathered off that and streamed in real time as they're manufacturing parts. So we use technologies like that, kind of hot path technologies, where we can stream live data from a machine into these event hubs, and then use services like off to the right here in the center, Azure Stream Analytics, tools that can read that data in real time and then do something with it, push it to storage. You see some of those, storage providers there, services there, like Azure Storage Blobs, Azure Data Lake Store, Azure SQL Data Warehouse. So there's just a plethora of storage areas once you receive data or ingest data into the Azure cloud. All it means is it provides you a ton of options to put your data somewhere. And then this notion of, I know you guys have talked about it before, and it's just something that can't be understated. This notion of and separation of compute from storage means that, hey, I don't buy a database and storage and they're all coupled together. Right. If I land all my data right in a data lake store or blob storage, I can bring up different compute engines. It's almost like the database or these Databricks clusters, they're just temporary compute like programs that we bring up when we need them to do some query or loading work, and then we tear them down when we're done with them. And the fact that we can have these multiple services operate in the same data in one place, allows us to really have your cake and eat it, right? You don't have to be, it's not an either or situation, either or this service or that. You can choose what tool or service makes sense for your organization and operate in that data in one place.
So in your customer's case, on the left-hand side, I'm kind of picturing, the flow from left to right, that's the ingest path going to a landing zone, and then the right, there's a lot of reporting and analysis options. But so these logs, they're coming in via, using something like Azure Data Factory to actually process these as they're arriving or being uploaded from the CDN. Is that what you guys?
In this case, we didn't use Data Factory. We were using different copy mechanisms. But
okay,
Anthony, you may have an update on it. I think this particular customer is now doing a different ingest path to get that data into storage.
Yeah. So they started with just running some Python scripts to pull the data from an FTP server from a CDN provider to land the data to Azure Storage. And they're also kind of at the same time kind of looking at Azure Data Factory as well. So they're still kind of determining what that ingest service looks like, but they're pretty much swappable in terms of how do you get the data in. When you want to kind of orchestrate the end-to-end pipeline, so hey, I want to pull all my data in, all these different data files, but now I want to process it and then I want to do something else. That's where Azure Data Factory has some nice pieces for the orchestration of getting the end-to-end pipeline. Okay,
so in this case, their vendor uploading log files, the FTP, to some landing location or some Python scripts that take that, move it into storage, and then ultimately you end up doing stuff with it from the analysis and kind of processing side in Databricks. So kind of the following the red thread, so to speak.
That's the flow. Yes.
Okay, got it. Okay.
Yeah, and we'll get the next couple slides. We'll get in a couple of the common right, cold and hot path type approaches to gathering data and making it accessible. And then I'll just quickly finish up on a slide. I mean, like I said, off to the right, so the center, once you've landed data, you can do a lot of refinement, aggregation, curation of the data there. It's a very common pattern when we're looking at big data, right? We pull in a lot of data sources. It's a lot to handle. So why don't we really aggregate it or refine it and shape it into a format that's going to be consumable for different personas or different business segments, perhaps, in your organization. So once we've done a lot of that refinement with these big data tools like Azure Databricks, right, then it becomes more accessible to reports and dashboards like you see Power BI at the top right. And then even the machine learning aspect is very significant, how quickly we can take data scientists and allow them to use tools they're familiar with, RStudio or working in Python, and actually, push their algorithms or models right onto the Azure Databricks cluster. It's a pretty short ramp up for them as well too, instead of just working on a workstation isolated by themselves. So all these services up in Azure, and we'll see some of that in the demonstration parts as well, how easy that becomes.
Okay.
So this is taking that previous slide, that eye chart on the previous page. This is a typical batch architecture where you have a lot of data sources, and whatever means you use, maybe it's Azure Data Factory or just a FTP job or whatever, you typically land that data into some type of storage. And more, Azure Data Lake Store and blob storage are kind of converging in terms of capability. And, we've seen generation 2 of data lake storages come online recently, and it's providing all kinds of new scenarios. But that seems to be that's our future direction and go-to is the data lake store. And of course, on top of that, then you can bring different services like Databricks Spark, our own internal Azure Data Lake Analytics tool called uSQL. So these different compute engines can operate on this big data and then do something with it. Like I said, maybe refine it or aggregate data and then push it into something like a SQL data warehouse service or another H-based cluster, something you provision in Azure, and then off to the right provide all kinds of reporting. So this batch architecture or cold path is a typical something similar we did for this customer, right? We were taking that 600 gigabytes of data, doing a bunch of batch transformation with it, landing it somewhere, and then making it more accessible for other types of business intelligence tools.
Okay.
The next slide is a typical streaming architecture. So you had seen it like down on the bottom ingestion point here, event hubs, IoT Hub, Kafka, some of the open source services for large message or event type ingestion. So this provides like a real-time streaming. So we can land data, as I mentioned, quickly from things like maybe in your manufacturing, a PLC or a vibration sensor on a machine or electrical meter on a machine. We can capture all those messages in real time in mass at millions per second, push them to technology like IoT Hub. And then from there, we can use tools that can stream that data in real time as well. And the use case we're talking about here, this is probably the ultimate goal is for them to use something like Spark streaming to take this weather data from some of their providers almost in real time and capture that weather data and Spark stream it into perhaps a Databricks table that at the same time gets pushed out perhaps to a SQL data warehouse and an analytical data store and then made available for very near or very real-time reporting.
Okay, so for this use case, though, these are just capabilities in Azure that facilitate, streaming and real-time analytics. You mentioned them exploring this for weather data, but for processing and analyzing their logs to be able to make informed decisions about how consumers are using their service. That's kind of more of the previous slide where you have them, batching this data and it's being processed on 24-hour intervals, I think you said, right?
Right.
Okay. All right.
So this would enable new scenarios, right? The ability, maybe if you're a restaurant chain or a customer, you need to know whether in more or less real time that impacts decisions you're making right in the store with preparing food or whatever. If you're a restaurant chain or something, so this streaming architecture would allow that, up to the second or up to the minute type of processing that real decisions you're making about the day.
It could even have a use case around these log files from the CDN provider, right? So, hey, if all of a sudden we're processing this and there's a lot fewer number of API calls than we're expecting, hey, what's going on? Is something occurring? Is there an issue?
Yeah, that's a good point.
True.
That's a good point. Anomalous behavior analysis.
Maybe something's broken in the platform.
I think that's often overlooked as another great value out of data is when things suddenly disappear. Yep. People don't think about that often. They usually go, what else? But anyway.
Yeah. Okay.
Cool. All right, so we've talked about Databricks, but really what is behind that technology? And it's important to know that Databricks is really a commercialized product offering of the open source Apache Spark. And Apache Spark has really gained a tremendous amount of popularity over the last 5 years or so. And what it is it's this distributed data processing engine that really provides some pretty fantastic performance and ease of use. So, to simplify things here, what is a distributed processing engine? Really, it's the idea to take a large amount of work to be done, to break that work up amongst different machines in a cluster, and different virtual machines in a cluster, operate on that data individually, and then return that result set to the client. As we were first trying to schedule this use case, it was kind of around the Halloween time, and that's a very common analogy that I see for distributed processing engines is if you think through Halloween candy, like maybe perhaps bags of M&Ms. If you had a bag of M&Ms and you wanted to count all the ones in there, you could probably do it pretty quickly. But what if you have tens or dozens or hundreds or thousands? For a single person to do that, it's going to take pretty significant time. But if you can get some friends, all of us together, we start operating on those individually, we can ultimately perform that job.
Yeah, that's a good analogy. So really, it's using kind of high throughput compute, behind the scenes because and Azure can facilitate that or surface that in an expedient and easy manner to customers because we have, within the realm of physics, virtually unlimited compute capacity that customers can tap into.
Exactly.
Yeah. Okay.
And the way that it's doing this, it's passing this work across the different machines in the cluster. It does that through this in-memory engine, and that's one of the ways that it achieves a lot of its performance advantages versus a Hadoop-based technology, where it's very common for the Hadoop when it needs to move data across individual nodes in the cluster or storing intermediate states or steps of the job. It would write those intermediate pieces to disk. Where the Spark technology tries to operate in memory as much as possible to get those.
Okay. Okay.
So what are some other reasons that Spark has gained this popularity over the couple of years? And that comes to that it's really unifying a lot of these different data processing capabilities. So not only can I do batch processing, I can also do stream processing or real-time processing. I can do machine learning. I can do graph processing. I can even work to handle interactive SQL and data requirements. All through all of these APIs that are exposed to you, that you get to pick and choose which language that you would like to work with. So in terms of learning curve, some of these languages that you can work with in these APIs, someone in your organization likely has one of these skill sets. So the languages that you can work in, Scala, Python, Java, R, SQL, likely going to have someone in your organization that can work with this to speed up your ease of use. So me personally, I came from a pretty big SQL background, so being able to work in SQL was a huge benefit. But I was also pretty surprised by how quickly it was and how easy it was to learn the Python language as well.
Yeah, and that's the example I used earlier. The customer that I was working with, their data scientist had a pretty good background in Python, and the little bit of instruction on what Databricks can do, they were off and running.
Right.
So yeah, cool.
Right. So Azure Databricks. So kind of we talked about the different data services. We talked about Spark now. Well, Databricks. What is Databricks? So Databricks is this commercialized product offering that builds on and enhances open source Apache Spark. But it's also offered in Azure as a first-party service. So that's pretty unique. What that means is you don't have your own credentials to access the Databricks environment. It uses Azure Active Directory. It's a single sign-on environment. To get to this collaborative workspace, you're going to the Azure portal, you're opening the workspace, that opens another browser entry, you get that single sign-on pass-through so that you can get started up and running and developing quickly.
So customers could deploy this in their own environment, right?
So it would be in their own environment inside of the Azure platform or AWS?
Yeah, well, I just mean like an on-prem, it's a commercialized product. I was just curious on.
No, it does not work on premises, no.
Okay.
Sorry, Ryan, you can't steal this.
No, I just wanted to air that out. That's sometimes a question. What?
Yeah, no.
Okay.
Yeah, you could potentially set up your own Apache Spark clusters on premises. That can be done.
Okay.
But you wouldn't be running Databricks on premises.
Yep. Okay.
Yeah. I guess the next train of thought here was, being that first-party services, it has a lot of this native integration with a lot of the other Azure services that we talked about previously. So being able to, once you process that data, land it to some other services, whether that's just pure storage, whether that's SQL Data Warehouse, Cosmos. If you want to visualize that data with Power BI, that integration with these other Azure services really works pretty nicely as well.
Okay. Oh, cool.
All right, the last slide on Azure Databricks here. So what are some of the features, functionality it offers? It offers this collaborative workspace, think Jupyter Notebooks, but it has Databricks' own kind of spin twist on it. And this really provides a lot of different end user types to collaborate in a single location. So you can work from a single notebook, you can add comments. It provides the ability to, once you've actually finished your notebooks and you feel like it's ready to go, you can productionize those jobs and workflows through some schedulers. You can also set up things like alerts and notifications when things may be failing. And that's all going to run on the optimized Databricks runtime engine. And a lot of the features and functionality for the APIs are exposed through various REST APIs that help you get up and running pretty quickly.
Do we have tutorials? Do we have like a place to go where a customer can start working with maybe some examples? Yeah, probably out of GitHub.
There's plenty of examples out there. So probably docs.microsoft.com/Azure.
Okay.
Kind of walk through getting started documentation there. And I'd be shocked if there weren't links in there to various GitHub repositories as well.
Okay.
Okay. Yeah, if you have any to share for the audience, definitely pass those along. We'll get those in the show notes.
Yep.
Yep.
Our subscribers want to know.
So what did the solution architecture kind of look like for this given customer challenge? So, we talked about this a little bit, but this hopefully puts it into pictures for you to more easily comprehend. So really that data loading piece, how do we get those FTP files into Azure? So that's, that data factory / Python scripts that we're running. And it's ultimately going to land that to Azure Data Lake Store. So that's where we ingest everything. We then use Azure Data Factory to kick off a Databricks notebook that's going to process those files. And it's also going to create some Hive tables so that we can start to visualize that both interactively through different notebooks, but you can also start to visualize it through Power BI as well, Power BI Desktop.
Okay.
So at this point, there's been no human interaction from data load to table creation to prep for visualization, right? Because when you said it kicks off a Databricks workspace, that kind of flipped the flag on for me. It was like, oh wow, we really can create data in an automated way and save ourselves a lot of cycles.
Just
right?
Triggered by the upload from their vendor.
Right?
Yeah.
Exactly. Yeah, there's no human interaction other than the analysis that's happening at the far right of the screen.
Cool. And I'm out of a job.
All right. So you said you had on that note. So you said you had some demos to kind of walk through a little bit about how this works.
Yeah, we do.
Very very curious to kind of see how it's all assembled there. So now we're going to click into the brick, right? I was holding it up earlier, but
click on that. I want to see this. Hey, it will be on YouTube forever and ever and ever. It will go viral today.
Morning, Bill.
Right.
All right, so let's get started and show you what this Databricks environment looks like. What's it all about? So here I am in my Azure portal. I have an Azure Databricks service spun up. And this is where you can start to see what that integrated AAD authentication looks like. So I can just click Launch Workspace. It's going to pop up a new tab in my browser. It's going to go through the AAD sign-on. And in a second or so, we should see what this Databricks environment looks like. Great. So here we are. This is going to be your main landing page. Some things to pay attention to, probably the clusters. So everything's going to operate on a cluster. Here I have my interactive cluster set up called Sparky. This is where you can kind of edit the configuration. So there's different runtime versions. I can run different versions of Python. There are virtual machines under the cover, although we're not responsible for kind of maintenance, patching, any of that. We're just picking a size that's going to have an associated memory and cores with it. And this is one of my favorite pieces to Databricks is the automated scaling that's built into it. So I can say, hey, I want my minimum number of worker nodes to be X, and I want my max number of worker nodes to be N. And this little checkbox will enable auto-scaling. So it'll look at the amount of work to be done in the cluster, and if there's jobs that are in a kind of a waiting or a queued state, it'll automatically scale up slowly and slowly till it hits that max workers for me.
So it allows you to contain the cost then at that point. So you can
cost, yeah, exactly.
Yeah,
And it'll automatically scale down
I don't
as well.
notice here too is that I don't see where, like in our VMSS services, you set the thresholds for the scaling event. This looks like it's all, again, abstract away from customer. What our best practices are, our choices of when we scale out those nodes.
Along those lines of containing costs, one of the big things, sometimes you'll wake up in a panic with, particularly HD Insight clusters. Hey, did I leave my cluster up and running? That's going to consume some significant consumption.
Never.
This feature to auto-terminate is really handy. So,
Okay.
hey, if I forget to turn this thing off or no work's being done, just go ahead and kill that in the background for me.
It's kind of like the shutdown rules on a VM. So it's a good way to again, help control. Okay.
So with that defined, just being a development environment, I got it set up pretty simply here. So just between 1 and 2 worker nodes. But from there, we can get to the workspace. And the workspace is kind of this notebook-based environment where we can collaborate on different projects. So inside my demo, I'm going to head over to this specific notebook called API Ags, or aggregations for short. And I'll kind of walk you through what this looks like. Really within this notebook, you'll notice that we have some different parameters or widgets defined at the top. And that gets to that kind of batch processing nature of this. So what we want to do is data is going to be stored inside of our data lake, and it's going to be partitioned into different directory structures based on the year, month, and day, so that we can operate only on the specific files that we're interested in. So will be utilized inside of the script here.
So we kind of glossed over that just to quickly highlight. We've used the word data lake often, but it's just a repository that you can dump data into with some rules to kind of define how it's using your word partitioned or physically stored, to be able to access and retrieve it. And it's accessible by services such as Databricks, right?
Exactly.
Yeah.
In simplest nature, a data lake is a distributed file system that doesn't have any sort of limitations on file size.
Yep.
Ooh,
Okay.
ooh.
Unbounded. There you go. That's a good way to. Okay.
Gotcha.
Yep.
So if we take a look at the script, the first thing that we're doing here is this is some Python, and really it's just defining structure to those underlying files. So it's a comma-separated file, these gzip files that are coming across, and they do have structure to them. So all I'm doing here is I'm going to define my schema that we're going to utilize. So, hey, it's got dates, it's got times, it's got IP addresses, it's got tokens and different things. So we're really just defining the structure. We define the file path that we want to read from. You notice that I kind of got this commented out. This was kind of more production worthy. This is definitely a simplified version, but hey, if I just got a single file in terms of demo purposes, I'm just reading from this mount point, and that mount point is pointing to blob storage, and I have a container and a directory, and I'm going to read all the given files with a .gzip extension from that container. The next piece is to call a spark.read, and everything's kind of self-explanatory in terms of the options here. So hey, my file does have a header. I'm not going to infer the schema. I'm going to use the schema that I defined just above. So that API log schema is exactly this thing here. So what's the schema or format of our data? It's going to be tab separated. If we have any sort of issues with bad data, to your point, we can drop those malformed rows.
Okay.
And we're going to read it in as the CSV file.
So it'll drop just the malformed rows, not the entire file. Okay.
Interesting. Okay.
And there's some different options that you can have there, but for this, any sort of bad rows, we were just dropping off. Yeah. So this all goes to a thing called a data frame. So we can then work with this API log. This is going to be this data frame. Think of it as really kind of a table. It's got rows and columns once we've read in all those files from the file system. And we can do different things with it. So we did some other advanced things here, like, hey, it would be really nice if we load all this data. It would be cool to understand which rows within the files we're able to understand that. So, hey, which rows of data came from this file versus here's just all the data, rows and columns that came from hundreds of files or thousands of files. Let's just append, let's get the file name and the specific source date, and let's append that to the data frame. And then finally, we create a thing called a view on top of that data frame so that we can start to work with it in the SQL API. So I just run like a control execute that's going to send this cell to the cluster, and it's going to execute fairly quickly, so third of a second. And then, because it's in that that view, I can then just use my own skill set that I'm very comfortable with in SQL, and I can just query this in SQL. So now I have a data frame. I can run it. It'll execute it against the cluster, and I get to start to see the results. So we can. This is the first piece. So apply the structure, then take a look at what the data looks like. So you can see I have dates, I got times, I got IPs. I can see the different APIs that they're hidden from that URI step.
Oh man, that's cool.
Yeah. So this is a good way to do some exploratory work to see, what does your data set look like that you're actually going to work with to kind of pass on to subsequent phases. So this is a kind of the iterative approach you take as a Databricks developer, really.
Exactly.
Yeah, okay.
That's cool thing. Cool. You can see what kind of devices are end users using. Are they using iOS, Android, what versions of all these things? But if you'll notice, like I talked about before, we need to kind of break this apart so it can be analyzed. Like this isn't all that helpful when it's in this long query string. So what we'll do in this next step is let's start to break this apart and define specific columns or fields for these different pieces of these stems or different pieces of, the user agent thing here. So This is I'm not going to go into too much depth here, but this is what that looks like in SQL. So we've got some case statements, and we're splitting based off of the URI stem here. So this is kind of the data transformation. How can we get break apart these different data elements that were previously stored in one column and get them into their own separate data columns for analysis.
Okay.
So if we run that little guy there, that'll run. And then what we can then do is run against that new view, and we'll start to see what things look like. So if we take this, for instance, we can see, okay, here's my endpoint, current conditions, and the type of endpoint. Is it daily versus hourly? And are they looking for the 5-day forecast or 72 hours? So we can start to break that apart. And ultimately, we can then start to analyze it a bit easier.
Okay.
The next piece, what we would do is then log that into a table. So as the batch processing runs, let's get this into a single entity, and we create Hive tables for this. So this goes to we're inserting the data into this API. I'm not going to run that.
How would you, for those familiar with like the relational database world, how would you compare a Hive table to a table in SQL?
Very, very similar.
Yeah, I mean, I obviously you're querying it similarly. I just didn't know if you had a. Okay, so that's Spark's way of being able to make it easier to be able to do things like this in a structured manner and be able to get data back out.
Exactly.
Okay.
So then we can do our traditional analysis. Hey, how many rows of data came in for today? And so things like simple count star. So you can see. What do we got? 1.8 million rows. This was just a single file, but when there's thousands, obviously we talked about the data volume, that grows pretty rapidly. And you'd be shocked really by how fast when you scale it up to the number of cluster nodes that is appropriate, it returns very, very quickly.
It's just a million rows, Ryan. Just a million.
Yeah.
So then you can see you can do different things. Hey, I'm interested in a specific hour, and I want this specific endpoint type. You can then run those queries, get results very interactively. And you're not
that's actually crazy fast when you think about.
I was going to say, see how quick it's coming back.
Yeah.
And when there's more data, it also
because this is you said you were accessing it in a kind of a relational way, but it doesn't have indices and all of the other things that kind of go along with a relational data store. So when you think about
nothing to make it fast.
Yeah, when you think about that, and you have a where clause in there, and your some criteria, that's pretty cool.
It's not to say that there isn't other optimizations that you could do under the covers, but look, he wants to make it go faster. I love that. Oh, we can make it. It's not that slow.
Yeah.
Another cool thing in the notebook is you can also, you're not just restricted to rows and columns or single results. You can also get graphs and start to change the data type. So here we're just plotting a simple column chart, and we can see, what are the endpoint types that are.
You had me at graph. Okay, I'm good.
So that's really what I wanted to show you. Kind of just a brief introduction to what the Databricks environment looks like. See how you set up the cluster. See how you can read it in the data set, apply some structure to it, and then start to query it in a language that perhaps many of you are familiar with in the SQL language.
And not to put you on the spot, Rich, but you got some big shoes to fill here, bud.
All right. Okay, yeah. So this last notebook, if you look up at the top, I just call it R scripts, and you can see right next to it R. So, Anthony kind of explained there's different notebooks. You can create it with the default interpreter for Python or Scala, R in this case, and even SQL. And so I created this notebook just really as kind of a learning experience for myself, and then show it to some of the people at this customer, so that would more be along the lines of data scientists or statisticians. So if you notice here, there's this little %SQL command in this first step and these next couple steps. And that says, hey, I know this is an R notebook, but treat this next command for this cell as a SQL script. So as we showed before, simple things like creating or replacing a view is just a select against a data table you may have out here. And so typical things we would do is just do select on some data, maybe a group by, in this case, agent and hour, and order it, and then return that count. And then in this next one as well, so here's a similar query to what Anthony was showing. I just want to show, now that I created this view up in the first cell, this V user agent, I want to select star from that where row count is greater than 10,000. So I can go ahead and Control Enter, execute that. And you see it comes back, again, pretty quick. It's the same data that we were looking at before, but now that I've got this view, it's aggregated up at the agent and hour level. So this is when we talked earlier that maybe you want to aggregate data for certain personas or user business groups, business segments in your organization. They may want just this optimized data every hour or every day, just to look at things like counts by different clients, and maybe they specifically do something with it. So nothing too terribly difficult here. But then, how do we take some of these temporary views and put it into a data frame? Things like data scientists are used to, right? If you work in R or you work in Python, you're a data scientist, you work with things called data frames. So it's as simple as taking a select statement against that same data set or one of your tables in your cluster, and this little notation here, my DF or my data frame, with this pointer here to the SQL statement, will create a data frame. So once I have a data frame, if I'm a data scientist, then you can do things like you can look at the structure of that data frame, and you can see what it's composed of, and from the different data types and features that are part of that data frame. I'll skip past this one. So once I have a data frame, then I can do things that a typical data scientist. I can use these libraries like ggplot2, and I can use Spark R libraries to do things like plot my data. So here's another data frame creation where I'm just saying, hey, select from this view I created above, and again, give me the agent, the hour, and the row count, and then I want to go ahead and plot that data frame. So nothing terribly exciting here, but if you're a data scientist, I mean, ggplot2, there's just hundreds of different visuals you can make. So you can see it aggregating across the x-axis by hour, and then by row count off of the y-axis. So you can see in this particular query, a lot of the hits are happening in this 50,000 or below at this, between the hours of 2000 and midnight. So just a simple plot. Is there a question in there?
No, and then I noticed too that it also is done in less than 8 seconds. So that's good.
All right, so we'll move to the next cell. Just a couple more here. So it gets a little more interesting. So if I create a data frame again, and in this case, I kind of changed the name here. It was another actual client name, but I want to select for that for a specific client who maybe who's generating revenue for me because they're using my service heavily. Then I want to look at when are their peak times and what are the main those endpoints Anthony showed before. What are the main endpoints and how are those being hit across a day? And you can quickly see how that breaks out. That definitely hourly and there's some unknowns in here, but the hourly type forecast seems to be hit a lot, and you can see the different peaks throughout that 24-hour period.
Oh, that's insane. It's just amazing how rich the data can be so quickly, just how to bring it back.
And again, the other thing on scale, we're looking at a relatively small file in this use case, right? Like 1.8 million rows, but when we were hitting it on a day level, I don't remember what the total count was, Anthony, but it was in the billions of rows, and we're getting, we're generating these graphs and charts in the same amount of time. This one took, and this actually was an old run against the entire cluster back in April. You can see the date down there.
Yeah.
I just saved this cell for display purposes, but this was like in 3 minutes across that whole 20-some terabytes of data doing this type of aggregation and generation.
Dude, I mean, I have witnessed multi-million-dollar data systems go into companies and never be able to do things like this quickly or ever achieve these types of goals ever. And companies struggle, the departments who justify the expense of these struggle to keep their jobs because there's like, business like, I need something to come back, right?
To typically need very high performance disks and
I mean,
And again, you're talking to an old timer like me, so I kind of take this for granted now, but man, I was the one that did all that planning to buy that kind of.
Yeah.
And it was not expensive. We're in multi-millions of dollars. Now we're spinning up, $10 million clusters here if we need it for just 5 minutes of work and tear it back down to get these kind of results. So
there's
mind-boggling when you look at the whole what we're doing here.
Yeah, there's three-letter initial companies that made their billions off of this stuff doing it on premise.
Absolutely.
Won't mention them, but just three.
Yeah.
So I think this might be the last example. This is one of the built-in data sets called Diamonds, just to show you some of the full richness of like these plot libraries that are available to people who work in R, and you can do some pretty much rich visualizations. And then when, the real statistical work, when you look at things like quantiles and residuals, fitted models, and probabilities and all that. So you got all that richness. So again, if you're a data scientist, you're looking at a few lines of code here in the Spark Databricks cluster. But if you're a data scientist, the ability to attach to that cluster and do this at scale, most of these guys in the past have they got a powerful workstation, and they still can't load 600 gigabytes of compressed data day into that workstation. It's just But now they take that subset, get it working in our workstation, then just simply take their scripts over here and put it in a cell and generate this kind of analysis against the entire data set and the entire cluster. So again, just mind-boggling what they can do at scale with big data.
So thinking about like the business problems that this actually solve for them, like how did this change or alter their view or lens into data? Before, I mean, that sounds like they had access to these logs, maybe not as readily able to consume and digest them as this extended to them. I know you said that they were using HD Insight. Maybe they were doing something to this degree, maybe just not as easily. Is that just trying to kind of to net it all out in terms of business value, to your customer?
So in a lot of different ways. I mean, one, they need to make sure that clients that have access to the different APIs are utilizing them based on kind of the criteria that was in that business agreement. So they can now start to analyze that more efficiently to make sure that people aren't making tons more API calls than they should be.
Okay.
But what they're looking to do now that they can do this so easily and they can get different groups of users collaborating in this central environment, they're going to pull in additional data sets so that they can, our API spikeage tends to happen when different weather things happen. Then they can use that for different ads that want to get shown, things along that nature. It just helps them understand their business a lot more efficiently.
Okay.
Yeah, we just kind of touched on that a little bit, the collaboration, but like Anthony showed, the workspaces, right? You could have these shared workspaces, and you can give permissions to different business groups and that to see their work. And again, these notebooks are so self-documenting that you can go through and see the analysis that someone went through to get to these types of plots and visualizations, and then you can simply borrow that work or create a new notebook. So I mean, the collaboration environment for data scientists, again, on a cluster at scale, is just it was something, again, that was very surprising to both Anthony and I, how easy it was to.
I'm thinking back to the days of yesteryear when we had large Excel spreadsheets with macros and pivot tables, and those are kind of difficult to shuttle around. And this is a self-documenting, self-describing way to be able to allow data scientists to be able to to interpret the data in a much more collaborative manner, and then certainly having way more access, or having access to way more compute power than they would on their desktop. So,
Yep.
Well, very cool. Well, thank you guys both for coming on.
Yeah. Thank you, Rich. Thank you, Anthony.
Really appreciate it, and clarifying that it's not really in a brick. So.
No. Sorry, Ryan. So disappointed.
Yeah.